So, did you ever wonder how to boost your platformer game with some ladders to allow players to climb between sections or reach high up hidden treasures? Cause this is actually pretty easy to do in Godot. Now in this tutorial, I'm going to assume that your level is built based on time maps. This is a pretty common way of doing level design for 2D games, especially platformers, and if you're curious about how that works, feel free to have a look at these other tutorials I made on that topic. But okay, let's say you have designed your level with time maps, and here and there you've got some ladders. Our goal will be to let players move up and down those ladders, leave them by moving left or right, to fall back down on the ground, and even jump onto them. So of course, the first step is to actually know if the player's avatar is currently on a ladder. Because in that case, we'll need to use some special logic instead of the default move left and right or jump with gravity-based platformer system. To check for this, the trick is to use Godot's Area 2D node and to set up our reference tileset with some physics layers. Cause basically, by giving the player object an Area 2D, we'll become a sort of walking ladder detector. And so whenever our avatar's area catches the presence of a ladder trigger, we'll know that we could start to climb a ladder. Okay, so first, start by properly configuring your time map for your ladders. Note that here I've separated them with their own time map layer node, but you could absolutely put them on the same layer as your other objects or your terrain tiles and it would work the same. What you want to do is, in the inspector of your time map node, access the tileset resource referenced inside, and here you'll get this physics layers section, where you can create special physics properties for your tiles that you then apply to each tile independently to your liking. In our case, the essential thing is to have two physics layers. We need one that collides with the player, so that we actually have a ground and walls, and we don't just fall through the ground. And we need a second physics layer that doesn't collide with our avatar, but that is on a specific layer that our area will be able to check for. Once you've reproduced that setup, you can go to the tileset editor at the bottom of the screen, navigate to the Paint tab, and pick your two tileset physics layers one after the other to paint the colliders for your tiles on each layer. So for the first layer, the colliding one, you'll want to give colliders to every tile that should be actual terrain and ground stuff. For example, in this tileset based on Kenny's platformer art tile sheet, I've given colliders to those tiles to have them block my player's avatar. On the other hand, for the second layer, you only want to paint the ladders. Alright, so with all that, let's now hop into our player scene and handle the detection side. This scene is a typical 2D platformer avatar setup with a character body 2D as the root, its collider defined by the collision shape 2D child node inside, here I'm using a capsule shape, and a visual node. In my case, that's an animated sprite 2D with various animations for each of my avatar states. And if you want to learn how to make this setup step by step, then I've also got a tutorial on that topic that you can check out. But in this scene, the interesting part is in fact the area 2D at the bottom. It has its own collision shape 2D child, of course, but this collider uses the exact same shape as the body above it, because we want our player's detection area to be exactly the size of its body. And the last important thing here is that, as you can see in the inspector of the Area 2D node, it needs to look for objects on layer 2, since this is the layer of our ladder's special triggers. All the logic is handled by the player's script. In particular, you'll notice that our Area 2D has two signals to detect when a body enters or exits it, and both signals are linked to callback functions in this script on our player node. Okay, so what exactly does this code do? Well, the Area 2D's callback functions and the detection part is actually really simple. All we do is trigger a Boolean flag in our code to memorize if we're currently on a ladder or not. The true meat of the code is in the physics process function, although we also use a new constant to allow us to customize our climbing speed easily, And we also have a second climbing boolean flag, which I'll talk about in a minute. So if you're a bit familiar with player scripting in Godot, you know that the physics process is typically where we handle the movement of our physics-based avatar. And indeed, here, this code takes care of both the normal system for our 2D platformer character and the special case of moving on ladders. It is based off Godot's built-in 2D character body script template, except I've added quite a few checks to take care of ladders and animations properly. Now, I'm not going to go through this code line by line, because a lot of it is about tweaking the visual, or showing the right animation in the animated sprite to the node. And that's not really the subject for today, actually. So let's rather just have a look at the overall gist, and so here, the idea is the following. At the very top, we start by checking if our character is currently grounded, thanks to Godot's built-in, available on any character body 2D node. And we use the input API to get our horizontal direction, if any. Also, don't forget that in C# we needed to create a duplicate velocity vector to be able to modify it during the function, and finally reassign it at the end. Then with those variables set up, we're actually going to see if we're currently over a ladder or not. If we are, then we'll check for the vertical input keys as well. This way, if we're currently pressing up or down, our character will move along the ladder as expected. Or else it will freeze at its current vertical position, thanks to this vertical velocity reset. Cause yeah, the crucial thing to note is that the gravity computation is only applied if we are not over a ladder, cause otherwise our character would simply be brought back down every time we try to climb up a ladder. Now, as you can see, the climbing boolean flag that we saw earlier is mostly here to handle animations. In short, the issue you might face when designing this kind of system and working on visuals and animations is that you'll need to differentiate between the player just standing in front of a ladder or having actually started to climb it. So this is what this extra flag is for. It allows me to see if we are actively using the ladder or not. Then below we check for the jump input or for the horizontal direction inputs, and we update the velocity to match in a very similar way to what is in the default character body 2D template script, with just some additional visual related things. And so at the end, in C# we reassign our new velocity vector, and in both languages we actually apply this velocity on a character thanks to the move and slide built-in. And well, that's it. If you try this out, you'll see that your character can now move normally in your platformer level, but when it gets over a tile with a ladder, you'll be able to use your up and down input actions to actually climb it. But yeah, in any case, I really hope you liked this quick tip. Don't hesitate to react in the comments and subscribe to the channel to get more videos, and of course a huge thanks to my Patreon members for the support and to you for watching. And as always, take care.